Hi, my name is Andrea, and today I would like to discuss with you a bit about the concepts of artificial intelligence and machine learning. So I bet that majority of you, when you hear the phrase artificial intelligence, you probably think about some science fiction movie that is set up in the distant future, world is in the chaos, and the robots and machines are becoming smarter than us and maybe taking over the humanity. Okay, we'll step aside from all these SF movies and go back to the reality. Although in reality, even though this might come as a surprise for you, we are surrounded by artificial intelligence and machine learning on an everyday basis. And probably each and every one of you is using these algorithms on a daily basis. So what are those? For example, we have Facebook newsfeed. And the algorithm behind Facebook newsfeed is that it learns on everything that you do. If you scroll to read some post, or if you like some post, it will learn from these things. And in the future, when you come tomorrow and open your Facebook newsfeed, you will see some more personalized post that matches to your search and your likes from the day before. But this is not the only example. We have Netflix, for example, where it matches your future movie recommendations based on the movies that you watched previously. Also, Siri is looking at the traffic jams and predicting traffic jams based on Google Maps. There is also, for example, Apple algorithm that recognizes your friend's face once the photo is being taken. Also, vacuum cleaner, for example, that maybe some of your moms are using, that it recognizes the place around the house and it moves freely without bumping into things. So all of these are examples of machine learning algorithms. And I hope that with this I convinced you that it is really everywhere around us. And considering the fact that we are living in the era of data and that we are constantly generating more and more data that we need to also store somewhere, we need to also find some patterns and meanings and associations from all of this data. And this is exactly where these machine learning algorithms are coming from. So to start, let's first give some basic description on the terminology. We can consider artificial intelligence as the broader term, and then the machine learning is just one of the most commonly used applications of artificial intelligence. And with this, I would like for all of you to make a pause in this video and to think with me, what is learning? So when we think about learning, every learning process should begin with some sort of observations, some data. And then we would look for patterns in this data, and based on these patterns, we can actually make some predictions for the future based on these initial experiences and hypotheses. So when we speak about learning in machine learning, this actually means that the system is acquiring the ability to perform the task. And it can acquire this ability in two ways. So first, we can make really detailed and complete set of rules that we would give the system to learn and to perform the task. And this would be typical classical algorithms. But in this scenario, if you imagine that we need to give specific and very detailed instructions on how to perform a specific task, we would need to consider of all the possible scenarios and opportunities that can happen. And as you might imagine, this can be quite tricky in some cases. So we skip to the second option that we have, and this is in fact machine learning. And this means that we can program the system in a way that it learns through the initial set of data that we call training data, and then we apply this model on the new unseen data by the system, which we call test data, and then check how it performs and if the predictions based on this initial model are good or not as good. And this is, in most simplistic terms, machine learning. So if we would want to make a clear definition of machine learning, we might say that this is a system's ability to automatically learn and improve from experience without being explicitly programmed. And when we consider machine learning, we must take into account three components. So first is the data, which is quite obvious. Then we have features that we also can call parameters or variables. And these are basically the stuff that we want your system to look for. And thirdly, we have algorithms. And these algorithms means various models, mathematical and statistical models, from which you can choose what would fit the best to solve your problem. So when we speak about the classical machine learning approach, we actually have two different aspects. We have supervised learning and we have unsupervised learning. In supervised learning, we are actually giving our data points some labels, some meaning that we already know from before. And based on that, we are making our predictions. On the other hand, in unsupervised learning, we don't have any labels attached to our data points, and we are simply using, in an unsupervised way, how to make some patterns, predictions, or associations within our data. So if we would want to consider in a more simplistic way the distinction between the supervised and unsupervised learning, consider that you have an encyclopedia of animals. And then if you look through this encyclopedia, and in supervised learning, you would see the picture of the animal, you would read and generate some of your own characteristics of this animal, but you would also in the end read the label or the name of that animal. And so you would train the model, and in the end you would know what is what. But in unsupervised learning, you would again go through this encyclopedia of animals, and you would look at all the animals, and then you would decipher what are the different characteristics of all of these animals. And based on these characteristics, you would try to group the animals either based on their color, their shape, whether they have wings, do they have fur, etc. And this is the form of unsupervised learning. Again, if we speak about the distinction between these various models, we can go one step further and see that among the supervised learning methods, we have two most typically used. Those are classification and regression models, where the only distinction between the two is that in a classification models, we are actually making our predictions and in the end hoping to get a yes or no answer, so based on categories. And when we speak about the regression, we are trying to answer the question on how much, how many, so any sort of numerical value. And if we are speaking about unsupervised learning, one of the most commonly used models are clustering, or we can use it as a dimension reduction method or to form some sort of association. Maybe it would be simpler if we have a look at one example of unsupervised learning on the basis of how would you place kebab kiosks, kebab stands, in the city, for example. So first you would randomly distribute 3, denoted by stars, kebab stands all around the city. Then you would let the people to choose for themselves to walk around and see which people from which area in the city are most commonly going to which kebab stand. Then you would move these kebab stands more closely to where majority of people is coming to this specific stand. And then you would see how the people behave. And then you would do this process over and over and over again. And in the end, you would find the best possible solution. And you would actually have 3 places in town that is fit for majority of the people. And you would have 3 distinct clusters or groups of the city where each group, majority of the people is going to that kebab stand. So quite simple and easy. So to sum up this whole story about the machine learning, supervised, unsupervised learning, I can say that it really enables us to massively analyze large quantities of data, and this is particularly in handy when we speak really about every aspect of our daily lives. If you want to consider some medical aspects, for example, or in science, just imagine that you're a scientist and that you're collecting patients' data from many patients, and that you're collecting numerous clinical characteristics of each of those patients, and that you also have, for example, the data for each of those patients on their 20,000 genes. So you would have huge number of data for many patients, many genes, many clinical variables, and you would need some sort of a smart way to find some patterns, associations, and use it to predict some future outcome. But two things that I would like you to remember at the end of this lecture is that your machine learning models are only as good as your data is good. And we have our typical saying, garbage in, garbage out. Another thing that is important to remember, that there is never only one unique way to solve the problem. There will be several algorithms that would fit with your data, and it's up to you to choose which algorithm fits the best. So I hope that you had fun listening through this lecture, and I hope that you learned something new about the machine learning and supervised, unsupervised learning, and that you're not intimidated anymore by these concepts of artificial intelligence. And as you may see, it's really everywhere around us. And if you would like to know more about it, please take a look at our handbook for the project. Thank you so much.